We are going to be talking today about lines. Linear functions are really important in mathematics. We use lines quite a bit because they're easy to work with, and I call this a review of lines. And that's funny, I can't draw a line. I call this a review of lines because you've seen this before, right? So we see it again and again. That's the thing about mathematics, is you get good at mathematics by seeing things over and over again, maybe in different contexts, in different situations. But we really like lines. We like to try and model data with lines if we can, because they're easy to work with. In calculus, when you get to talking about instantaneous rates of change, we're going to talk about slopes of tangent lines and all that stuff. So lines are quite important, and they will keep coming up over and over again in your mathematical career. So let's just, we're just going to do some definitions, stuff you've already seen, remind you of a couple things, do a couple examples. Call good. So first thing, let's just talk about what it means what does a line mean, right? So I asked this question in my classes, and I'll say, what's a line? And of course, if I asked you to draw me a line, you could draw a line, right? But what is a line? So if you think about what a line is if we're going from one point to another of anything that's on that line, it's the same slope, right? It has the same rate of change. So between any 2 points on a line, I'm going to go up the same amount and over the same amount, or some, ratio of that to get to the next point. So a linear function, lines are functions. Remember, we talked about the vertical line test. It passes a vertical line test, obviously. For every input, there's one and only one output. So a function f is what is said to be a linear function, or we just say is linear, if it can be written. Wow, there are very loud people outside of my office, so sorry if you hear that. In the form. And this should be a familiar form to you, f of x equals mx plus b. This is lovingly known, right, as slope-intercept form. Here's the thing about mathematicians. This is what I love about mathematicians. Well, that's what I love about myself, I suppose. If we say it's slope-intercept form, what are the two things you can get from looking at this form? You get the slope and the intercept, because that's what we call it. We're not going to give it some fancy name or anything, or use flowery language. We're just going to call it slope-intercept form, where, right, m is the slope. We'll define slope here in a minute. We know what slope's going to be. And 0, comma b, remember the intercept is a point, and 0, comma b is the y-intercept. So when I ask you for the y-intercept, it should be a point. Okay, it is a point that it goes through. 0b is the y-intercept. So we know that kind of stuff. If m is equal to 0, I would have f of x equals b, which is just a constant. That's a constant function. That's just a horizontal line. If m is 1 and b is 0, we just get f of x equals x, which is what we call the identity function. So a couple things here, couple notes under this here. Horizontal lines are of the form, and so you've probably seen this before, y equals b, or if we think of it in function notation, f of x equals b. Same thing up here, everyone. I know you probably know this. However, remember, f of x is the same thing as y, right? So a lot of times when you first talk about lines, we don't maybe know what a function is quite yet. And so what we want to talk about is y equals mx plus b, because that makes more sense to us when we're talking about the x and y axis. So, you're welcome to use f of x, but I will be using f of x or y interchangeably when I'm talking about lines. So horizontal lines are of the form y equals b. So for example, like if I had y equals 3, think about, everyone gets confused by this, but what I dare to do this, I ask you to think about what this means. I don't have any x's in there, right? So x, this is the thing, x is free. X can be whatever it wants. It can just go back and forth on the horizontal axis and do whatever it wants. But what is my y value forced to be? 3. So no matter where I am on the x-axis, my y value, right, must be 3. So I'm going to grab a bunch of x values. What is y always going to spit out? It's always going to spit out 3. That is why, my friends, are we friends? I think we're friends. That is why y equals some constant is just a horizontal line. Whereas what is a vertical line? So a vertical line is going to be kind of the same thing, except vertical lines are of the form x equals some number. So sometimes we won't use b because we'll just, or of the form x equals a. In this case, you guys, listen, better not use function notation because this sucker right here, not a function. So let's think about what can happen here. Remember, y can be whatever it wants. So all my points can be vertically whatever we want, but x is going to be fixed. So if I look at something like x equals 3, right? Y can be whatever it wants, but I have to have the distance from 0 in the horizontal direction be 3. So that's how I get a vertical line. Why is this not a function? I can hear you. You remember the voices in my head that I've talked about before? You're saying, because it doesn't pass the vertical line test, Sarah. I'm like, yes, you're exactly right. Good job. Doesn't pass the vertical line test because remember the vertical line test says for any vertical line that only passes through the graph once, exactly once. And clearly if I took a vertical line that lied right on, I'm not sure, was right on x equals 3, I would have an infinite number of points where it cross. Okay, so you know this stuff. This is really, really good stuff. Linear functions are pretty simple, I think. So let's look at the idea of slope. So we define m to be the slope, and that's what really defines kind of what a line is. And so slope, we're going to just talk about the slope of a line. I care about slope quite often because I guess I'm a skier now, just because I want to hang out with my family in the winters. But my husband is a skier, and now my children are skiers, and they're very good. I, by default, am a skier. Why am I talking about skiing? Because I care about slopes. I'm quite passionate about slopes being very gentle when I go skiing. So I care about nice, easy slopes. I want a slope that's like has a fraction, right? Like a fraction slope. I don't want to slope it like 3. I want to slope it like 1/2. Okay. I can get down a hill with a slope of 1/2. My daughters, however, go down hills with slopes of quite higher than that and negative slopes. So anyway, I digress, which is common, as you found. What does the slope mean? Slope is just talking about how do I get from one point to another. So if I'm looking at the slope of this line, what I want to know is how far in the y direction and how far in the x direction do I need to go to get to another point on a line. You guys know this. And a lot of times we use this little triangle to talk about the change in something. So that means change. So in this case, if we talk about our slope then, we're going to do the change in y on top and the change in x on bottom. So we're going to do rise over run, right? And then another way we could say that is the change of y over the change in x. And how do we find change? Well, we've seen this before. Or how do I find distance? The distance we've traveled is with subtraction, right? So y2 minus y1 all over x2 minus x1. Doesn't really matter which one you pick first. Here's the thing you got to remember with slope. 2 things you need to remember with slope. Always y over x. That's one huge thing about slope. We always need to take the change in y over the change in x. Don't do it the other way around. Don't do x over y. Slope is defined to be the change of y over the change in x. And the other thing that my students always forget is be consistent with y's and x's. Now that doesn't probably mean anything to you. Well, not x squared. My mind is not, it just wants to go to math. What I mean by that is it doesn't actually matter if you take y1 or y2 first. It doesn't matter. But you need to be consistent. So if I choose y2 first in the top, I have to choose x2 first in the bottom. Same thing here. If I decide to go with y1 first in the bottom, or in the top, excuse me, I need to choose x1 first in the bottom. So quick example. Find the slope of a line passing through. So it doesn't make sense to say find the slope of the 2 points, this and this, right? Slope really refers to lines. So sometimes you'll see me being lazy, like find the slope between the 2 points. What I really mean there is find the slope of a line passing through the 2 points or between the 2 points. Let's say -1, 4 and 3, 7. I don't know what this is going to do. Let's see what happens. Again, it doesn't matter which one you pick first. I don't know what I do. I usually, if I have like a bigger number, I'm going to go ahead and take the 7 first. So I'm going to do 7 minus 4. Again, change in y. So 7 and 4 all over. Now I have to be consistent. 2 things I need to remember, always y over x. So I pick the y's. Be consistent. I chose 7 first, so 3 gets to go first in the bottom. 3 minus what? A -1, right? So what is that? That's 3 over, becomes a plus 3/4. So what does that mean? So that's a positive slope. So what that means is I know I'm going to be going up. That's a positive slope, right? A negative slope would look like this. And 3/4 means for every time that I go up 3 units, I'm going to go to the right 4 units. So the slope, I don't know how you describe steepness or not, but not as steep as maybe a slope of like 4, right? So I'm just going to go up 3 and to the right 4, and that's going to give me my slope. Okay, awesome, great, lovely, I like it. Could we graph a line if we knew that this line was in slope-intercept form? So remember, let's go back to this really quick. Remember this, oh, it's mad at me. This m right here is my slope. So now that we know what slope is, if we have a line that is of the form mx plus b, right, then I can actually graph it. So what if I had a -2/3 x plus 2? I want to graph this. So just by looking at this, I know a couple of things. I know my slope, right, is a -2/3. And from this 2 right here, I know my y-intercept is 0, 2. How do I know my y-intercept is 0, 2? I hear you talking to me. Look at, if you put in a 0 for x, this whole term goes away, and you're left with 2. Let's graph this sucker. Okay, people, I'm going to attempt to draw a line. It is not going to go well. I know, positive thinking, blah, blah, blah. However, I have years of data that tell me I'm not going to draw lines. So what I want to do first is I want to graph 0, 2. So there's my 0, 2. And now remember this slope. This slope is change in y over change in x. So this is my change in y over change in x. Now, what I like to do is take that negative. Remember that negative is kind of just in front. And I'm going to put that negative either with the x or the y. I usually put it with the y. Put it with the y. That -2 tells me to come down 2. And then that +3 tells me to go to the right 3. So I know another point on my line is going to be right there. What if I had put that negative with the 3? Okay, then that 2 is positive, so I'm going to go up 2, and then I'm going to go to the left 3. So I would have a point right there. Oh, look at that. And then connect the dots. La, 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 la. Oh, no. Oh, no. Oh, this is going to go bad. Okay, and if your point doesn't work, just like make it bigger. There's my line. Slope -2/3 and y-intercept 0, 2. You know how to do this. I believe that you have had this before. So I hope that makes sense. A couple things about slope. Note, horizontal lines have no slope, or it's 0. Horizontals. Horizontal lines have slope 0. That makes sense, right? So it'd be, remember, change in y over change in x. X can do whatever it wants. Y isn't going to change at all, so I'm going to get 0 over, 3 or whatever number. So I have 0 slope. I don't mind horizontal lines when I'm skiing. I have to do a little bit of work, but at least I'm not going down icy mountain on fiberglass. At least I'm on a flat slope. Vertical lines have undefined slope. Undefined because there's no change in x. So what you end up getting, dun, 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 is a 0 in the denominator, right? That's bad, 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 bad. We don't want zeros in the denominator. Actually, when we talk about vertical lines, we actually say they kind of have infinite slope. Like a number over 0, really, we say goes to infinity, but maybe you'll talk about that more when you go to calculus. Calculus is so much fun. All right, you guys. So that's the main stuff that I wanted to talk about with that. We're not one other thing. We did the slope-intercept equation. You can probably hear me looking through my book here. I do want to talk about one other form of lines that are important, because you might, what if I don't have a y-intercept, you guys? What if I don't have it? Here's the thing. Okay, yeah. Everyone loves slope-intercept form, right? Love slope-intercept form. However, slope-intercept form, I feel, is one of the less useful forms. It's nice, it looks pretty, it's fun to get y by itself. But point slope form is actually, I know you're not supposed to have favorites, right? But point slope form is my favorite. So I have 3 kids, and this is a joke. You don't have to call protective services, but I always joke that I don't have a favorite kid yet because I don't know which one is better at math. So once I figure that out, I'll find my favorite kid. Kind of like the same, it's a joke, kind of like the same thing with these lines. I actually kind of do have a favorite. They're both quite useful to me, but I really like point slope form, because point slope form, you can have any point on the line. If you want to put something in the slope intercept form, you got to have the y-intercept. I know there are ways around it. I know you can solve for b, but point slope form is just easy. You don't have to go around and solve for b. So let's talk about point slope really quick. So the point slope form of a line is given by y minus y1 equals m times x minus x1, where the point x1, y1 is on the line, and m is the slope. All right, so this is not, here's the thing. This isn't a mystery onto where this formula comes from. It's easy to see it. What I know is I know that slope, right, is the change in y over the change in x. So I'm going to do change in y over change in x, where x1, y1 is a point that I know my line passes through. And then this y and x, this xy, is any point on the line. And by definition of what slope is, you guys, that slope has to be consistent for every single point on that line. It has to be the same slope. That's what gives me the line. So if you notice here, if I just multiply both sides right here by x minus x1, right? Look at what I get. I get the slope, point slope form of the line. So it's nothing, I mean, it's fancy. Poor point slope equation. You're fancy, but it's nothing like mysterious or anything like that. So let's really quick find the equation. Let's find the slope, or the slope-intercept equation. Equation of a line passing through the points let's just grab some points here. 2, -1, and I don't know, 5, -3. Okay. So first thing you need if you're doing slope intercept or point slope, both of those forms have the word slope in it. So you need slope. So let's do that first. So I want to find the slope of my line. So I'm going to do -3 minus a -1, change in y's. Which y do I have to use, or which x do I have to use first now? I have to use 5 minus 2. So these are going to become addition. Oh, this is nice. I don't even get a fraction. Well, technically it's a fraction, right? But it's a whole number also. Oh, no, I don't. I was thinking that was 2 on the bottom. Sometimes arithmetic, the higher I got in math, the worse my arithmetic skills got. All right, I get -2/3 again. Isn't that what we got before? Apparently I like -2/3 today. -2/3. And now what I want to do, so notice neither one of these are y-intercepts. How do I know that? How do I know they're not y-intercepts? Because these are not zeros. Okay. Now I know you can plug this into y equals mx plus b and plug your y and your x in and solve for b, but I would like you to practice using point slope form, okay? If I ask you to use the point slope form of the equation, If you don't use the point slope form of the equation, you will not get full credit for a problem. So what you want to do with this point slope form of the equation, right, is I need a point it goes through. It doesn't matter which point it goes through, whichever one you feel is nicer to you that day, whichever one you like better. I like 2, -1 better today. I don't know why, I just do. So I'm going to take y minus my y coordinate, so minus a -1 equals my slope, which is a -2/3 times x. Now I have to use that 2 first. Okay, because I use the -1, I have to use its buddy 2 right there. Okay, there's my point slope form of the equation. But look at what my instructions asked. It wants a slope-intercept form. So slope-intercept form means I solve for y. I'm going to take the -2/3 through. You are not scared of fractions. You are not scared of fractions. This is 2/1, just multiply them. Don't freak out. You are not scared of fractions. So what is the slope-intercept form of this equation? I'm going to subtract 1. 4/3 minus 1. 1 is the same as 3/3, so it looks like I get 1/3. So there's my answer. Going from the point slope form into a slope-intercept equation is pretty easy. Okay, -2/3 x plus 1/3. Now, why is the slope-intercept form nice? Of course, because we can see the y-intercept, right? And we know the slope is there right away. But to get it to that form, use point slope form. Point slope form is a great, great form for doing that. All right, people, 2 more things and then we'll call it good. Some interesting pairs of lines that we could deal with are parallel and perpendicular lines. So parallel lines, what are 2 parallel lines? Well, in 2 dimensions, in the Cartesian coordinate system, right? Parallel lines are lines that never touch, right? So what's the way that we're going to have them never touch? If I draw a line like this, if I draw any other line, if I draw that, do you see how eventually they're going to intersect? So what do I have to have then for my lines to not intersect? They have to have the same slope. They have to be increasing or decreasing at the same rate, or they have to be vertical lines. Okay, so parallel lines. So first off, let's just say vertical lines are parallel. Why do we have to make that little statement? Because remember, parallel lines don't have they have undefined slope. So if I just define parallel lines to be 2 lines that have the same slope, we're leaving out vertical lines, and vertical lines wouldn't actually fit. But we know 2 vertical lines are parallel also. So, okay, so non-vertical lines are parallel if and only if, ooh, that's a big statement in mathematics, are parallel if and only if they have the same slope. And your book says different y-intercepts, so that's fine. That just means it's not the same line. That's all. We don't want it, parallel lines are not supposed to intersect. So if it's the same line, that doesn't make sense, right? It would intersect an infinite number of places. So parallel lines two non-vertical lines are parallel if and only if they have the same slope and different y-intercepts. Quick thing about this if and only if. This is a really, really strong statement in mathematics. What that means is that this statement is true this way, meaning if they're parallel, then they have the same slope. And it's also true the other way too. Means if they have the same slope, then they're parallel. If and only if statements are pretty powerful in mathematics. And if you become a math major, when you become a math major, if you become a math major, and you have to prove a theorem that has if and only if, you have twice the work. Okay, so perpendicular lines. What do I know about perpendicular lines? We know that perpendicular lines meet at a 90-degree angle. What do I know about their slope, though? Look at this guy right here. Notice this is a pretty, not super steep, but it's a slope that is positive, and this one is negative. So parallel lines, you might remember, have opposite reciprocal slopes. So let's write that out, and then we'll say that. So we'll talk about it. 2 lines with slope. Let's define their slopes. Let's just call them M1 and M2. Let me get rid of that guy right there. Are perpendicular if and only if, and now I'm going to be really, really lazy here. This is shorthand, mathematicians. This is shorthand for if and only if, because heaven forbid I have to write out 4 words, right? We have, at some point, I'll write you an entire sentence with no actual words. That's like a theorem in mathematics and only symbols. So this just means if and only if in mathematics, because I'm lazy. I'm lazy, guys. If and only if the product of their slope is -1. What does that mean? That just means they're opposite reciprocals. Why? I'll show you. Don't you fret. I'll show you. Okay, so if m1 times m2 is equal to -1, if I solve one of these, then look at what I've shown, that m1 is a -1 over m2. So look at m1 is the reciprocal of m2, and it's the opposite sign. That's it. They have opposite reciprocal. I mean, flip it good. Slopes. Okay, that's all that means. Opposite reciprocal slopes. All right, guys, let's try one of these. Let's have a good time. Like, but Sarah, we're already having a good time. I know, I am too. Let's have even more fun. So, for example, consider the line. And these lines can look, you know, different than what we think. Doesn't matter what form it's in, really. Consider this line. So find the equation of a line passing through (0, -1) that is parallel to that line that we're given. And then for part B, oh, it's going to be a good time. We're going to do perpendicular. Find the equation of a line passing through 0, -1 that is parallel to that line right there. Okay, so here's what we know about parallel lines. Same slope. And what else do we want? What is this guy? What do I see right away? This is a y-intercept. Yay! So what is my goal? My goal, because I have a y-intercept right here, is to get this into slope-intercept form right away. Not right away, but eventually, right? What is slope-intercept form? Y equals mx plus b. So look at that, guys. I already have my b. What do I need? Again, in both of these forms, point, slope, slope, intercept. What do we need? Slope. So how am I going to find my slope? Well, what do I know? I know that I am parallel to this line right here. So I'm going to mess with this line because I know that parallel lines have the same slope. So if I can find the slope of this line right here, I know that's going to be the slope of whatever my line is going to be for A. How can I find slope? Pretty easily. I can solve for y. I can force this guy into slope-intercept form, and then I can find my slope. Might have been just as easy to add the 6y and subtract the 5. That's probably what I would have actually done, but I don't know. I don't know why I'm doing it this way then. Divide by -6. And what do we get then? We get y equals what? 1/2 x minus 5/6. Okay, so what is the slope of this line? The slope of this line is 1/2. So what is the slope of the line that I care about? The slope of the line that I care about is also going to be 1/2 because we're talking about a parallel line. So the equation of my line then is 1/2 x, but now I don't want -5/6, right? What is my intercept? -1. So there's my answer. 1/2 x minus 1. And if we did a quick sketch, this is the best part. I love doing this. I should have thought about my y-intercepts a little bit differently, but that's okay. 1, 2, 3, 1, 2, 3. Oh, I really should have thought about my y-intercepts a little bit differently. Yeah, darn it. Well, if I graph this guy, -5/6 is not quite 1. I know that's like 1/2, but I'm going to put it so it's not quite 1. The 1/2 says I'm going to go up 1/2. So there's my line there. That's the original line I started with. And then I'm going to use some purple here. This guy, I'm at a -1. Should have chosen my y-intercepts a little differently. But if I go up 1/2, notice, remember pretend these are lines. Pretend. Those are not lines. That is so bad. Oh well, that's okay. It's okay. I still have worth as a human even though I can't draw lines. But notice they're parallel. Isn't that cool? I love those. That's so fun. All right, let's do another example of this. Let me get rid of all this stuff right here. I'm lazy. Remember, I'm lazy. Good mathematician is always lazy. Now I want one that's perpendicular. Maybe I shouldn't have gotten rid of all that stuff, but. And I don't want to go through 0, 1. Let's go through something else. So find the equation of a line. Nope. I need to get rid of the eraser. Line passing through, let's choose something else. How about 1, 3, and it's perpendicular. Okay, this is the last one, and then we'll call it good. Okay, and it's perpendicular. So remember, I found the slope of this line, right? We had y equals 1/2 x minus 5, 6. So my slope of this line, I'm going to call this M1. Actually, let's call it M2. Is 1/2. So what do I know about the slope of the line that's perpendicular? Remember, my M is -1 over 1/2. You don't have to show me that step. We really just think, what's the reciprocal of 1/2? It's 2. Also, this 1/2 is positive. What's the opposite of a positive? It's a negative. Done, done, and done. Well, not done, but all right. So let's put it into an equation. It just says find the equation. So I'm going to use point slope form. Oops, that's not point slope form. And a lot of times I'll let you leave your answer in point slope form. I don't care. -2 times x minus 1. There's my equation. Now, there are some of you out there who cannot sleep at night without making sure that this is in point slope, and you are welcome to put it into point slope. All I did was take that -2 through and add the 3 over, okay? So either one of these, unless my math lab is telling you something different, I am good with either one of these being your answer. And now for the fun part, we want to graph this. These are so much fun to graph, you guys. Now, it's going to be a little tricky because of my y-intercept. If I had thought about this a little bit, which, why would I think about things before I start recording them for them to be held on YouTube fame forever? It's going to be a little tricky. -5, 6, I'm going to put right here. I'm going to go up 1 and over 2, right? Or I could go down 1 and to the left 2. That would work. So here is, oh, that line wasn't horrible. There's my yellow line. And now let's graph this guy right here. I know I go through the point 1, 3. So I'm going to go up 1 over 3. And now look at, guys, my slope is -2. So I'm going to go down 2. Remember, that's 2 over 1. I'm going to go down 2 and over 1. Or, right, I can go up 2 and to the left 1. Oh, this is so cool. Hold on, I need to get that point a little better. This is, guys, I'm kind of a dork, a little bit of a nerd, because I get like excited when I graph these. Because you can kind of see, oh, that's so not a line, but you can kind of see that it's perpendicular to that yellow line. Isn't that great? Just love that. So anyway, those are perpendicular and parallel lines. I know that was really fast going through that, but this is stuff you should have seen before. Lines are pretty important though, so it was worth the time to go over it. Let me know if you have any questions. I hope you enjoyed it.